This is, well, I should probably look over here. It's the top one that we're doing, right? That's the movable one, right? Yeah. Okay, the question is, can you get a textbook out of the heavenly doctrine? Should you? Some people think, no, it's not, doesn't reveal science. I already talked about that. I gave Niels Bohr's answer to Einstein. I think it fits. Well, I kind of done it. I'm still working on the questions for the students. It's been a lot of fun. About 4 years ago, pretty much, I think it was about 4 years ago that Brett asked me if I could teach physics. And my answer was only if it's new church physics. Went home and realized I didn't know what that was. I have a much clearer idea now. For the last 4 years, this has been my main job, is trying to find it. And it is amazing how many things were in there. So I was told we're only meant to have 1 or 2 burning bush moments. There's been about 20. But I'm not going to get into all of that. As a matter of fact, I won't get to the last law because there's just not time, but I will quote it now because it relates to Angela's paper and what Steve said about a stream of conscience, that it's actually moment by moment. It says, all activities are changes of state and variations of form. And the latter comes from the former, meaning variations of form. And what Angela said about form to form, it's a verb. And it goes on to say, in man, state is his will. Changes of state are affections. The form is the intelligence. Changes of form or variations of form are thoughts. So we're going through that all the time. So the stream of consciousness is a constant variation of form from one form to another. And we usually just look at the form. We don't see the state within it. And here and makes some sense. Kurt told me it's going to be tough. It's some new ideas. And So I talked about the affirmative principle earlier. I wonder if we could turn the mic down a little. It seems to be just a touch. Is that okay? Okay. So the question is, well, let's go back again, how should we proceed? Well, we're told how to proceed in the affirmative principle. We should proceed from the true order, which is to be wise from the Lord, that is from his word, and then all things follow. Another way to put it is thus his starting point, which is the word principle, must be from the Lord and not from oneself, for the former is life and the latter is death. So we don't actually begin from our senses. We take our shoes off. We don't think from the senses. We think from what the Lord has to teach us. And this is where for years, probably 40 years, I've known this number. I've given it to students to compare it with Newton's laws, which we will get to in a bit. But this is an outline for a course on mechanics and physics. It's a wonderful outline, these 4 laws of order and influx, which is inscribed in the nature of all real things. But notice this affirmative principle has 4 things in it about science. That he's enlightened in rational and scientific things, in no way forbidden to learn the sciences, and from thinking and speaking as do the learned in the world. Now, this thinking here, he wasn't thinking that we should think like an atheist, because there's a lot of scientists that are atheists, but to think about the scientific things, hopefully more like what Angela said, and do it in terms of the familiar to the learned world as far as possible. Now, do the heavenly doctrines do this? Do they talk about science in terms of the learned world? Well, I needed to find out what the terms of the learned world were at the time the heavenly doctrine was given. And these books here, Concepts of Force, Concepts of Mass, and Concepts of Space, I think Stephen got me onto this book years and years ago, probably 50 years ago. Well, I remembered these books, so I bought them and read them. And neat thing about Max Jammer, at least in those books, back one, what Max Jammer does in these 3 books, not so much in that one, Concepts of Simultaneity, but these 3 books, he leaves the quotes from these authors in Latin. So you actually, if you look at the Latin of the writings, you find the terms in the learned world. And it was interesting, they had at the time it was called the vis viva controversy, and they were trying to figure out what is the force that makes nature work. And Descartes had vis movens, or the moving force, from within. Vis viva was, as we're going to see, is more like energy for Leibniz. And Newton had what's called vis incita. And there's formulas for all three, which is kind of fun, meaning you can actually start looking at what the writings say. You can start getting some formulas, because that physics without formulas isn't physics. I know it's analytic, but okay. And so today we call these momentum, kinetic energy. Notice there's a half missing there. Well, that's Leibniz's fault, not mine. He just said mv squared. It still works, it's still conserved. And then the inertia is the idea of the mass resisting the force. Now, interesting enough, while there's a vis viva controversy, there was also a controversy about influx. And if you remember the end of interaction of the soul and body, they had a debate between the Cartesians, the Leibnizians, and the Aristotelians. And physical influx is really the physics of Newton. Physical influx means the outside makes something happen. It causes from outside. And of course, the F is an external force in Newton's formula. So, does anybody know who the winner was? What? Yes, Descartes. He was the winner because obviously, no, they weren't settling it. The Cartesians did not win the argument. It was settled by an angel giving them a lot to draw, and the truth led to spiritual influx. So it was actually, he won the lottery. That's how he won. They were not going to stop debating. Okay, so do we find these terms in the writings? Not very often. Vis viva fairly often, but notice this, it says there is also like endeavor and motion. No motion can come forth without endeavor, insomuch that when endeavor ceases, the motion ceases. Wherefore the internal of motion is endeavor, or moving force. That was the card. So it's fully, he uses it in a positive way. The next one is vis viva, and the writings use it differently. They use vis viva, the living force, as something that's actually living. It says the same is with the spiritual and the natural. The spiritual, because it is a living force, is active. And the natural, because it is a dead force, is passive. We're just going to go through these fairly quick. I'm going to dwell a little bit more on vis incita, because I found this about 3 years ago, and I wish I'd known it. So I apologize to Houghton and Dan and Sean and anybody else I taught physics to. Okay, yep. No, is that Rafe? Yeah. Well, no, I don't apologize to you because I taught it right to you. But Bennett, I taught it wrong to him. I taught there was such a thing. Well, this is what the writings do. The reality is that in all and each things, oops, too fast. The reality is that in all and each of the things in nature and her three kingdoms, there is something intrinsic acting from the spiritual world. A beautiful idea. And unless this were so, nothing whatever in the natural world could act as cause and effect, and consequently nothing could produce anything. And here's the really interesting part. What is from the spiritual world within the natural things is called an innate force, or vis incita, from the first creation. That's how Newton thought. Newton believed in God. He thought God put this force of what? Into it, but it is not. It is endeavor, on the cessation of which action or motion ceases. And where do we find this word, vis incita? In a book that Swedenborg owned. It would be nice to own one of these, first edition of the Principia. Anyway, on the first and second pages, so Swedenborg only had to read 2 pages of this book to know that it was called vis incita by Newton and by Newton's followers. The vis incita, I'll do the translation of the Latin here. The vis incita, or innate force of matter, is a power of resisting by which every body, as much as in it lies, perseveres in its state, whether it be at rest or moving uniformly in a straight line. whence this vis insita may be called by a most significant name, vis inertiae, or the force of inertia. So I taught inertia for 40 years, and then I came across this number. I actually found this number just a little before I taught Rafe and the other guys, and I'm happy I found it. No, there's no inertia. It's endeavor from the spiritual world, from influx that keeps things moving. So you can see what it says there. And when you do this relates a lot to what Angela said. Whoops, I'm going to jump here and then back to the other one. Very simple. This is physics in a nutshell. From influx is endeavor, from endeavor is force, and from force is the effect. Potts went and put an energy there for force. I don't know why. Anyway, it confuses it. And when we do this, when we see the endeavor in everything, then the universal visible world becomes a theater, representative of the spiritual world. I trust you had that number in your paper, Bennett, right?
I think I
Yeah, because it was a theater and a thicket. He wrote a paper on science, and science can be a theater, representative of the spiritual world, or it can be a thicket or a bramble with no fire in it. By the way, brambles do have berries, but they have thorns too. Okay, so we see from the terms of the learned world, the heavenly doctrine actually addresses the concept of inertia and says that's not the way it is, which is a remarkable statement. Now, this is the first law. It's a fun one. That nothing exists or subsists from itself or is acted on or moved by itself, but only by something else. That sounds a lot like Newton's first law. From this, it follows that everything finite exists and subsists and acted on and moved by the first that is not from another, but is in itself the living force, which is life. Oh, Newton forgot the second part here. And Leibniz chewed him out for it too, because he didn't mention God in his first edition of the Principia. He did add it in his second and third edition, but it was too late. The naturalists seized on this. Unfortunately, this was the beginning of, we don't need God, when of course we do. And I wanted to start with this one, but I realized these two laws say basically the same thing. It is known in the learned world that subsistence is perpetual existence, or you could say staying in being is perpetual coming into being. Thus, conservation is perpetual creation. That means what is conserved is perpetual creation. And Ian talked about propensity. The word in the heavenly doctrine for propensity is endeavor. And that's what's conserved. Which is, what are the three things conserved in physics? You're allowed to answer, Rafe, if you remember. Mass and correct. Get a prize. I'll have to get you something. Okay. So energy, momentum, and mass are conserved. And I am of the opinion, oh, there you go, the momentum conserved in the, oh boy, there's a video. This could be trouble. Let's see if I can go on. No, where's she at?
Because there are tired dogs in your area. There are drivers in your area.
Okay, there we are. The three faces of endeavor: energy, momentum, and mass. And believe it or not, they are pretty much the same thing in one way or another, because in relativistic physics, energy squared equals momentum squared plus the rest mass squared. Rest mass is the measure of mass when it's not moving. And that is actual formula. They have the same units if we make the speed of light 1, where it's a meter of space over a meter of time. A meter of time is pretty small. It's the time it takes light to travel 1 meter. And that's why light goes so fast. It's basically what you can say, since time corresponds to states of truth and space to states of good, that for every new truth, there is a new good. That's as fast as you can go. That's why it's the speed of light. You can't go faster than that, because you need the truth to do the good. So I think the only one who managed that was the Lord. We're going to be tough. Okay, so another fun fact is change in energy is force times the change in space. The change in momentum is the force times the change in time. And the change in rest mass is the force times a thing called an interval. And the interval's constant, so is the rest mass. Kind of fun, just a little thing I threw in there. I've never seen that written out before, but it's a fun little thing. That's what an interval is. It's sort of like Pythagorean's theorem, except there's a minus there. That's what makes space-time kind of strange. At any rate, moving on. So the breakthrough, so to speak, is that energy, mass, and momentum have an endeavor. And what is the endeavor? Well, in gravity, it's to seek the center, as we're going to see. So this is a second law, and this is a strange one. That nothing can be acted on or moved unless it is intermediate between two forces. Oh boy. Sorry. One which acts and the other reacts. That is, unless one acts on the one side and the other on the other. Unless one acts from within and the other from outside. It's pretty remarkable. And that idea of two forces we find all through the writings. For instance, it says there are always two forces, which as said before, keep everything in its connection and its form. Namely, the force acting from outside and the force acting from inside. In the midst of which forces is that which is kept in connection and form. So, what are the two forces on this man standing on the mountain? I won't pick on Rafe again. Gravity is one. And which is from outside? What's the outside force? Sort of. The mountain. You can feel it on its feet. Right now you can feel the chair pushing you up, right? Because gravity's pulling you down. Gravity acts from inside. Well, there's air pressure. There's a lot more stuff going on, yes. Physics, you get, Galileo realized he had to idealize things or it never would work. He dropped two balls from the Tower of Pisa and pretended they hit at the same time, right? Actually, I won't go into all that. Okay, so here's a harder question, and so you who came to my presentation at the assembly might remember this one. What are the two forces on the feather and hammer that David Scott dropped when he was on the moon? Now, this was Apollo 15 mission, okay? And he was one of the astronauts who actually went down onto the moon. And for the first time, they thought, wouldn't it be fun to film a feather and a hammer? You can see it's kind of hard to see. Even in the video when it's moving, it's very hard to see these things, because back then the videos weren't as good as they are today. At any rate, there they are together, both falling at the same speed. But what's the two forces? Momentum's not a force. Momentum makes a force. Endeavor makes the force. From endeavor, remember, comes force. And then the number, and the one that I think Clark read it, 218. Right. Both are what we call gravity. This is the way Wheeler sized up Einstein's theory of general relativity. Matter tells space-time how to curve, so it forms the space-time, and then space-time tells matter how to move. Space-time is like the outside force, or the gravitational field, we call it. And what's inside? That's what science doesn't know about. There's an inside force, an endeavor from influx that makes that force. And they're always going to be in equilibrium. It's fascinating. So at any rate, that's something that we should have figured out general relativity back when people were reading the writings, right? Didn't do it. This is a neat number about gravity, though, and tells you that the endeavor is to seek the center, right? The entire heaven turns itself to the Lord as to its common center. To the center do all angels turn themselves. Also on earth, as well known, there is a directing of all things toward a common center. But this directing is different in the world than in heaven. In heaven, the front parts are turned to the common center, but in the world, the lower parts of the body. In the world, this directing is called centripetal, which means center-seeking force or gravitation. So it's nice that the writing has told us that. That's the internal force, is the center-seeking endeavor that brings about a force on the inside. It's kind of hard to figure. Ian and I have been going back and forth on this one for a while. Here's the outside force. If we look at this I'm only giving the one ether, the purest ether. It says, the most interior atmosphere arising from the sun of the world is the purest ether, which is universal, out of which comes all gravitation. And you might remember the universal gravitational constant. And in another number in Coronis, we find that he's going to call it the aura. He does it in TCR and Coronis. He settles on 3 words instead of purest ether, middle ether, and lowest ether. He calls it the aura, the ether, and the air. And aura, I believe, is very similar to the gravitational field, which comes from the natural sun, and also from the earth to us and to the moon. Okay. Now, this was something I came across. I just want to show it because it sizes up the 3 first laws in one sentence, basically. And this, when I found this, it hadn't been seen for 250 years. This is in the first draft of the Apocalypse Explained. And he crosses this law and writes the different one, which I just mentioned. All activities are changes of state and variations of form. But first he wrote this. Can you read it, Kate? I'll translate it. That everything that is in the middle and in equilibrium is not acting on a move from itself, but from another that flows at it from outside and another that flows in from inside. I'm adding the other because there is clearly 2 forces, one from inside, one from outside. And it's this afflux idea. I didn't realize it before, but it's in the... Oh, there's a little picture of what that means. You recognize this equation? Ian will. That's Einstein's equations, actually, because these are subscripts of this is the gravitational field, this is the energy content that makes it. And he added this because if he didn't, the universe would be expanding. And then he took it out again. And now they put it back in again because they needed something to explain dark energy. So it's still in flux. But notice the ball. The ball has what we would call momentum, which is really the interior force from the endeavor moving it. And it's center-seeking. And the sun is what curves the space-time, or the gravitational field's a better name for it, so that the Earth follows it. And here's just a couple of numbers about afflux and influx. The influx is from the spiritual world and the afflux from the natural world, by which they're held together and live. And then the next number, I'm running through these because I don't know how much time I have, and also would like to have time for questions at the end if possible. Okay, so it says this is the influx, bursts forth and becomes active, whereas there's an affluence of a heat from the sun. When you get, this is the love of propagating. It's in accordance with the presence of the affluence of the heat from the sun. In other words, flowers grow, animals mate, and so on. Those who believe that the world's heat flows in and excites these loves are greatly mistaken. For there can be no influx from the natural into the spiritual, but only from the spiritual into the natural. So this idea of, and I wanted to add this. This is a fascinating number. I have it in Latin here because that's the only place you're going to find it published in Latin. This is from the first draft of the Arcana Celestia, okay? 5,709. He has a big section, this whole section he didn't copy in. Now the part I'm going to translate is just this first part, because understanding this is as simple as understanding good and truth. It's all about good and truth, right? Well, watch this. Truths can in no way be applied or selected except by means of good. For good is a spiritually active or living force, But truth is a spiritually passive or dead force. It's the only place you're going to find this teaching, is in the first draft of the Arcana. In other words, something moves from good on the inside, and it follows the truth. You love the Lord, you want to go to the Lord, but you won't find him without the truth, that he is the Lord Jesus Christ. Now you can go to the Lord, but you need both the love to do it, and you also need the truth to find it. So good moves it, and truth gives it its path, shows it how to move. Okay. Where did this? Oh, this is the end. Oh, I went too fast again. Here. For which reason, unless good is present, truth cannot be applied at all. For passive forces cannot be applied without an active force. Indeed, not without an active force related to them. In other words, they need to think. I'll just show you how that works. It's really easy. What's the active force? It's coming from inside, isn't it? Coming from inside me. What's the passive force? Floor, exactly. And according to Newtonian physics, the floor is pushing me around. That's the external force. Is that the cause? Well, think it's true of everything. It's true of, let's see, I can walk. Actually, I got to wait on this a little bit. Got to get a little further along. And when both those forces have been applied, then the active appears in the passive. Right? So we think the ball's moving on its own because the active appears in the passive. The reason is because the former acts through the latter, just like I'm me walking on the floor. Who can conceive of something ever existing in the world that does not exist from two forces, namely the active and the passive? So there's always an active and a passive force. It's actually a fascinating thing. Now, moving on. So that's the bit about the two forces. But here we go. Let's compare them to Newton's three laws. And it was in doing this is an exercise that I've given to my students ever since I've started teaching physics just about, even at the Bernathen High School. And so these are Newton's three laws. A body remains at rest or is in motion at constant speed in a straight line unless it is acted on by a force. At any instant of time, the net force on a body is equal to the body's acceleration multiplied by its mass. That's F equals ma. And then the two bodies exert forces on each other, and these forces have the same magnitude but opposite directions. That's action, reaction. If we compare the laws to the laws of order and influx, we see the first part matches up. But unfortunately, Newton left out the most important part of that law. In God we live, move, and have our being. So there's a difference between the laws, but they do sort of match up. Now, most of the students like to match them up 1, 2, 1, 1, 2, 2, 3, 3. They don't match that way. It's actually the second law of order and influx matches the third law of motion. You can see the words, for every action there is an equal and opposite reaction. And here we see the same words, one which acts and the other reacts. But look at the difference. The heavenly doctrine says the thing is in between two forces, not one force acting on the other like this, but two forces on this ball. One from inside, one from outside. So that's a difference, but this one, the third law is really difficult to understand at first. It's actually the crux of the whole thing. And since these two forces, when at rest, produce an equilibrium, it follows that nothing can be put in action or moved unless it is in equilibrium. And when it is put in action, it is out of equilibrium. For also that everything put in action or moved seeks to return to equilibrium. Now, the only part that really matches Newton's second law of action and reaction, of F equals ma, is this when it's put in action, it's out of equilibrium. In other words, it starts accelerating, which science would say is out of equilibrium. So when I saw that, I was grading Bethany Buick's paper, and she got it right. She matched them right, and then suddenly something happened. This. I realized acceleration is an object seeking to return to equilibrium and comes from inside and not from outside. So, here, the other one came at the same time. Free fall is a state of equilibrium, which is similar to Einstein's happiest moment. I really feel sorry for Einstein. If his happiest moment was discovering this, my happiest moment was getting married to my wife. And after that, the children. After that, maybe, the grandchildren. Einstein must have had not such a great life if his happiest moment was discovering general relativity, which is a pretty neat moment, but I don't know how he did. Anyway, so let's do this. This wants free fall, right? So now it's happy, unhappy, happy. Now it's, thank you, Kurt. So it actually wants to, now think of, I was going to do this with the baseball I brought, but I didn't want to hit the bat because it could hurt somebody. But a baseball gets thrown. The pitcher, I think that's the word, puts his endeavor into the ball. Now the ball is happy, it's in free fall. It might be a curveball, but we'll pretend it's a fastball, okay? And it's going right at there, and it's happy, and the pitcher wants it to be happy as long as possible so that the batter misses it, and then it would be in the catcher's glove. However, the batter hits it. Now it's unhappy. Now, I realize balls like to do what they do, which is to be thrown around. It comes from the Greek word ballo, which means to throw. So, at any rate, kicked, not so much. But free fall is actually equilibrium. And so when it gets hit, the batter puts his endeavor into it, and he wants it to be as happy as he can. I heard there was a ball hit out of the stadium the other day. You were telling me, Kurt, right? That's something. But the longer it's in the air, the happier the batter is, right? Unless it's a high fly pop-up, then he's not so happy. At any rate, this actually works. And this is what I found absolutely amazing was, well, I'll go, that one, that's 218. I'm not going to do that one. There. Did that one again. Okay. So I came to that conclusion about acceleration is seeking equilibrium and that free fall is equilibrium. And then I knew there was something about principle of least action in this. I don't know if you know anything about it. You don't need to. So I bought this book, which is The Lazy Universe. By the way, what's the Latin word for lazy? Yeah, inertia. It's the Latin word for lazy. That's when the writings have the word inertia, they mean lazy. Okay, so it's fascinating. She called the book The Lazy Universe because what she meant by it was things try to move in such a way that they use the least time and energy. That's the path they take. So this is a book by her, and it brings together a non-Newtonian approach to physics, which is really what real physicists do. Newton's physics doesn't get very far. D'Alembert and Maupertuis came up with the idea the same year that Swedenborg left science. When he was called to start reading the word, these two men wrote. One wrote The Principle of Dynamic Equilibrium, the other one did this. Euler was the one who made sense of it. He's an excellent mathematician. He went blind and was still doing math, sort of like Beethoven and his Ninth Symphony. At any rate, Lagrange and Hamilton are also very well-known physicists. Hilbert used the principle of least action to describe general relativity. And Feynman used it to describe quantum mechanics or quantum electrodynamics. Interesting thing is, Newtonian physics won't reach those two subjects. It doesn't fit. It has a limit, whereas this non-Newtonian approach to physics gets there. But this is what I'm reading. I got to page 88. See if you recognize something here. In essence, D'Alembert's principle proclaims that the very motions are exactly such as to bring the system, instant by instant, back to equilibrium. Well, that's what the third law was, remember? That things out of equilibrium seek to return to equilibrium. So every instant by instant, or I would say moment by moment, the thing returns to equilibrium. That's why the ball moves away from the bat. If the bat's hitting it, it wants to get back to equilibrium. And as it moves, the bat slows down a bit, and the things are constantly in and out of equilibrium as it moves, moment by moment. The principle relies on one radical new idea, D'Alembert's stroke of genius. It is that mass in accelerated motion counts as a force. So what D'Alembert did is he said, there's a force in inertia. Where from? He never answered that question. Was it simply a mathematical gimmick? So you can see the correlation between these two. What that meant was acceleration is the object seeking to return to equilibrium. I was kind of happy I got it from the writings rather than D'Alembert, but it was really fun to see that D'Alembert went along with it. Now, so I wrote to what I called her Madame Coopersmith, because she's in France, right? Anyway, I wrote her a letter and asked him, what did D'Alembert mean? Did he think it was a real force or not? And nicely, and also shared these two laws inscribed on nature. And she nicely wrote back to my question about D'Alembert's thought. And she appreciated my kind words, because her book really helped me see how I could do the math of New Church physics. And she answers about D'Alembert. I don't know what D'Alembert's views were. His writings are very difficult to read. The meaning is opaque. I think new ideas often come through in this way. A great thinker or mathematician can have an important hunch, but they nevertheless don't understand the full import of their ideas and their range of application. The true importance can be decades or even centuries come through. And she says, I know nothing of the writings of Emanuel Swedenborg. I shall have to look him up one of these days, but not now, because I'm spending a lot of time writing my next book. And she did say, I consider inertial forces as equivalent to and indistinguished from real forces in a certain local setting. So it was kind of interesting. So that's the stuff. All of those equations are equilibrium equations, from the force from within, the force from without, or in between kinetic and potential energy, you know how one switches to the other. It's all done with equilibrium. It's all done with two forces, one from inside, from influx, from endeavor, and the other from outside, from atmospheres. So I'm just gonna, let's see, what time do I got here? What time am I meant to quit? 2:40? I started at 2, I got 5 minutes, oh boy. Well, I got to do this, so sorry about that. I wanted to leave time for questions. Principle of least action, what is it? Well, you're here in the field, and you want to get to this spot on the other side, and I gave away the answer. Which one? Well, we just have to ask light. Oh, no, it's not there yet, sorry. I was looking at the side here. Which path do you want to take? The blue one, which goes straight? The one that takes the least time in the woods, that goes perpendicular, or the middle one that sort of bends like that? Which one would you take? Red, blue, or black? Yeah, black. Because look at what light does. Light tells us, light goes at the least possible thing. It's as if the light knows that it's going to end up at B. And this thought experiment, I'll just read this to end, because this is really neat. This thought experiment shows that light seems to know where it is going and figures out what path to take to minimize time and energy. Since for a photon, at a certain frequency, energy is constant. It is simply keeping time to a minimum. Now this is something, as I wrote this dawned on me. So this is what I'm writing at the time I'm thinking it. But I need to be honest here. I've loved the principle of least action for 50 years, ever since I learned of it in my quantum mechanics course, where it is said Mappertree proposed it for theological reasons. It shows there is purpose in physics. As Mappertree would say, it shows the wisdom of the Creator. But now I'm realizing as I write this, that this is a consequence of a much more important and simpler principle. The purpose of maintaining equilibrium is not the principle of least action. Creation is not about saving time and energy. The Lord will spend as much time and energy as needed to save every one of us if we are willing. Salvation is the end and purpose of creation, not efficiency. The principle of least action is a consequence of equilibrium being reestablished moment by moment. And it can be derived mathematically from D'Alembert's dynamic equilibrium principle. It is this law of equilibrium between the force from inside and the force from outside which permeates the heavenly doctrine that we find the real principle or starting point. What Maupertuis discovered was of tremendous importance. He discovered there is a specific end in view or endeavor within every, or I'm going to do it this way, within every movement of everything in nature, whether living or dead. But he did not see what the principle was. Yes, the mathematics of setting the goals of least action, as we know from both classical and modern physics, does indeed yield the path something will take over time and space. But the end in view is more lofty, more marvelous, more fundamental, and of greatest importance. Kurt's not allowed to answer. What's the purpose of equilibrium? Heaven, but he did answer. Freedom. The end in view is freedom. This is why equilibrium between two forces from influx and afflux is constantly maintained moment by moment. There is no greater motivator or endeavor in the spiritual and natural world than to be free. And I need to bring him up. This is what Fernando Carrasina said at one of our sessions. The Lord is continually creating the universe, and to what he creates, he gives freedom. And then he listens to the response as music to his ears. And I have to say this, electrons are much better behaved than high school students, okay? So, this is the fundamental law of everything. And this is a quote from the Heavenly Doctrine. I wrote it down, I didn't even see it until I got to that section on least action. I suddenly realized there is not a substance in the created universe that does not tend to equilibrium so that it can be in freedom. Isn't that amazing? And that's where the randomness in quantum mechanics comes from. Every electron's free to move. Free to go where it goes. And he's creating them so fast, you see them all over everywhere. But they go where they want. They're not going to always go to the same place. As a matter of fact, if we study the writings, they will never be the same as they were before. Every moment of a moment, they're a new creation and different from the electron before it, which doesn't make sense, but that's pretty much what the Heavenly Doctrine says. Well, I'm going to stop there, and I didn't leave time for questions, but I'll take one.